主要是蔡志祥。很高兴今天我们的场地比较小，然后我发现我们的报名非常的踊跃，已经超过我们场地可以容纳的数量了。非常感谢各位今天的参与。那今天我们很荣幸的邀请到Sean跟 Eric 来我们这边来分享他们最近在做的一个 open source project， 叫做 OpenMoko。我想各位，我想在座每个人应该都有手机。那手机其实在以往来讲，它其实是一个非常封闭的系统，你很难去在上面去开发软体，或者说去取得你想要的资讯，做一些你想要做的客制化的东西，比如你换离声、换不清楚屏，就很超多。但是 OpenMoko 它是一个很令人兴奋的 project。第一个，它是由台湾的公司所创立的一个 project， 是由大众电脑所创立的 project。那它的目的是要做一个完全开放的 platform， 所以你可以在这个手机上做任何你想要做的修改，这非常的让人兴奋，因为以前由 carrier 所控制的整个手机上的一个生态环境，以后会有一个非常开放的一个平台，你可以去随意的控制，随意的去做你想要做的事情。那接下来我们就会请Sean FIC 的 PM 来介绍 OpenMoko 这个 project 以及一些相关的发展。让我们鼓掌欢迎Sean。
Should we get started? Is this volume okay? Can you hear me?
Yeah.
Okay, so like Rex said, I'm a product manager over at FIC, but lately I've been doing lots of things that are not product management. And so one of these is OpenMoko, and the idea was to create kind of the one product that I've always wanted that's not out there yet. And found a whole bunch of people, Harald being the first one who also wants this kind of device. And we've been working really hard for the past year on this. And so today I'm going to try to just put things in perspective, why open source is important for mobile, and sort of why mobile is just kind of the hottest thing to be doing right now. And then, so this is kind of like the philosophy, if you will, of why you need an open phone. And then Harald is going to talk about some technical stuff, show you some demos, and talk about how, even down to the hardware, we're different than most people. So this is kind of like the rough agenda today. So first, I just want to walk you through the opportunity. What's going on here? Why we think mobile is so crucial. And so if you look at this, you look at consumer electronics as a whole, right? You have 47.3 million shipments of PSP to date. You have 5 million Nintendo DS game consoles sold in the last quarter, just in one quarter. 44 million iPods. These are pretty big numbers. 75,000 BlackBerries subscribers, new subscribers. Again, in a 3-month time period. But the very last number, this is where it's at. 1 billion phones are sold this year. 1 billion phones. That outnumbers PCs 5 to 1. So everything is going mobile now. If you look, phones nowadays are starting to work with TV, with video, with gaming, music, social communities, GPS. So mobile is this, it's becoming increasingly important to our lives. Mobile's flying. Mobile is what's moving with you. It's what's fast. Because your grandma, right? Chances are your grandma has a mobile phone. She doesn't have a PC. My grandma doesn't have a PC. She has a mobile phone. And farmers in China, peasants in India, they have mobile phones. They don't have PCs. The mobile phone is the future. Mobile is bigger than the PC in sales because mobile is walking. It's moving around. It assumes that we're going to bring things with us wherever we go, whereas the PC assumes you have a button, you're sitting on it. And that's it. So the future is that go on.
For a desktop, you need existing infrastructure, such as a desk.
Yeah. Yeah. Actually, there's a really, really funny quote. It was said by a guy in India, a good friend of Harold's. We were talking about desktops, and why aren't there more desktops in India? And the guy says, well, for starters, you need to have desks. So mobile really is the future, and what we think is that these phones will get more and more PC-like features, and you'll find a situation where the phone is every bit as powerful as the PC, if not more. It can do more because it's mobile. So we got this mobile thing. Everything's moving mobile, and then let's look at mobile as a market segment, and look at what's the fastest growing part of mobile. And this is smartphones. If you look at smartphones, it's the fastest growing sector. This is pretty small print. It says 77, so the year-over-year growth from last year to this year, smartphones grew 77%. The rest of cell phones grew 27%. So smartphones where it's at. OpenMoko, everything we're doing is focusing on smartphones, and this is the one piece that's really growing, and that's the Linux-based smartphones. And we're doing it really different than the other people. I'll explain this kind of later on in the presentation. This is just to kind of set the big picture, let you know why smartphones are important, why Linux is important. And this is a really interesting number. By 2012, 203 million mobile phones. This is not smartphones, these are just mobile phones. Will run Linux. Now, this is China. China's market share is almost double. Linux is almost double. So Linux will play an even bigger role in China. This is the Motorola Ming phone. It has about 8% market share now. It's the #1 selling smartphone in China. But here's some more interesting things. I actually read this only a few months ago and was just blown away by it. The mobile industry is roughly $230-something billion a year in revenues. And inside this, only the top three, Nokia, Motorola, and Samsung, only these top three make money. Everyone else loses money. I mean, really, really losing money. And last year, actually, by the way, Motorola lost a ton of money. So it could even be top two, I don't know. And the customers, say you have a problem with your phone, you don't like the way it works, you want to take an application off of it, you want to put a new one on it, for the most part you're stuck. So it really isn't an open ecosystem. And developers, before I was a product manager at FIC, I was a developer. I wrote software for PHS phones. And anyone who's written software for phones before, you know how frustrating it is. Every new model has new software, has new applications. You have to redevelop them more or less from scratch. You can't really share these things. But the key is that these closed systems kill innovation. And so I'm just going to take you through a couple of systems. This is a closed system. It's the phone world. It started off around 1980-ish with GSM. SS7 came out, IN came out, SMS, ringtones, GPRS, MMS. These are all really boring things. And now the most exciting thing is talking about TV. These are all things that you already have. You already have a TV in your house. You can already send text messages on your computer. It's called IM. You can do it forever. Emails, the same thing. And so this ecosystem, there really isn't anything that interesting coming in here. Look at an open ecosystem. Something that has a standardized open protocol. Anyone who wants to can do things around it. I mean, the most interesting thing about the internet is that if you're a very small computer or a supercomputer, to everyone else you look more or less the same, just an IP address. And so look at what happens here. You have new things like email, a web browser, but then you have things that are like companies. You have Amazon comes in here, Cisco comes in here, AOL comes in here. So you don't have just technology, you have a whole ecosystem. Everyone gets to go in and and make some money and everyone benefits from this. So this is what's wrong. The PC industry, right? This stuff here has been standardized. And because of this standardization, companies are then able to produce services, produce things that can work on more or less everyone's computer. Any modern desktop nowadays has access to more information than the Library of Congress, than any library in any bookstore period. In the mobile world, there isn't an open solution here. This is what OpenMoko hopes to fill, this right here. So this is kind of the philosophy. This is the mobile world moving in, trying to look at it. Now, why is open important? And obviously there's a hole there. Why doesn't Microsoft come fill this? And so today, what I'm going to try to prove to you guys, try to persuade you, is that the person you want filling that hole is an open platform. So, open levels the playing field. You don't have to worry, hey, can I license that software? Is it going to cost me $15 per handset, or can someone else get it for $10 and then I'm no longer competitive? If it's open, it's free software, you just get it. You don't have to say, do I have to ask permission to change this thing? You just change it. If you have a new idea and you think of how you can make the operating system run faster, you don't have to ask for Microsoft's permission. You don't need to wait for them to fix the bugs that you find in their code. You can do it yourself. So open levels the playing field. It's a very, very key thing here. And closed means that the only people who are earning money are the incumbents, the ones who are already in this industry. Like I said before, those top three, Nokia, Motorola, Samsung, they make money. Everyone else, my company included, loses money. A lot of money. So we're trying to change this. And then, this is the transition right here. The internet, right, has in a really short period of time become dominated by free and open source software. So I'm just going to take you through free and open source software, FOSS, really quickly. Just point out some things that I found like really surprising. I was looking at some research the past couple of days and found these numbers. I was kind of blown away by them. And skip all the definitions. I'm sure everyone knows what free software means, all licensing kind of stuff. But look at this. So from the web serving point of view, 70% or 71% really is Apache. IIS, 20%. This is a number from IBM last year. They say that the server has essentially been won by Linux. Last year, 83% of all new systems that they installed, that were being installed, servers, were Linux. Now, bind, right, the DNS, 95% of all reverse lookups, bind. SendMail is the #1 mail server. OpenSSH is the #1 SSH implementation. Free software is incredibly reliable. This is ZDNet, right? This is a company that if you read the reports, you know they're incredibly Windows dominant. Most of their writers are paid by Microsoft. They did a 10-month study. NT crashed every 6 weeks. Linux never crashed. They did another study where they took a look at the speeds of IIS compared to Apache. IIS was 2 times slower. So all these arguments about free software being, someone's hobby project, it's wrong. Free and open source software is more modular. This is really interesting. They did a study of 5.7 million lines of source code. And the industry average is you're supposed to have, I think it's something like, do you remember what it was percentage-wise? Anyways, they only found 985 problems once. It's 80% less than what you would normally expect to see in that many lines of code. So it's really, really, really high quality code. And anyways, some other little interesting facts there. Here's some more fun stuff. Free software performs, scales, and is more secure than proprietary software. GNU Linux with Samba, the file serving is faster. It serves Windows files faster than Windows servers can serve their own files. I mean, this is like really embarrassing for Microsoft. 78% of all supercomputers are running GNU Linux. 78%. These are systems that, of course, every little ounce of performance matters. 50% of the vulnerabilities that were found in Windows were critical. 10% in Red Hat were critical. 91% of broadband users supposedly have spyware on their home systems. Less than, or about 0% free and open source software users have it. Okay. So, what have we learned from free and open sources? When you have a truly open system that's based upon protocols, standards that are more or less open for everyone to get involved with, free software quickly dominates. It's more reliable, it's a higher quality of code, it's easier to maintain, it scales better, it's more secure. So we've seen that FOSS is more or less one, the server, and it really dominates the internet. It needs to start moving. Moving to where? Mobile. So OpenMoko is mobile FOSS. This is our software stack. I'm not going to spend that much time talking about it now. I'm going to let Harald handle all the technical stuff towards the end. I'll just point out a few things that I find interesting. First off, these middle white lines are components that we more or less had to write from scratch. We chose, whenever possible, to kind of take the philosophy that if it exists, we will use it and extend it. We don't want to write things, reinvent the wheel. The other thing is, if you notice this K-Drive Matchbox GTK environment, this is essentially desktop. The libraries that run on this phone is essentially desktop Linux. So it runs X. Within memory constraints, you recompile, the applications more or less work. It's a VGA screen, so we'll show you some cool stuff in a bit. The whole, really think of this as a GNU Linux distribution. It's not just a single product. We're not trying to make a product, we're trying to make a platform. And everything is built using Open Embedded. From the beginning, this is like before Apple announced all this iPhone stuff. From the beginning, we had the idea that the user interface needed to have key parts of it that are completely finger-based. You can really quickly pick up your phone and just start tapping on it and using it. So we have finger-based applications, and then we have stylus-based applications. And this is the thing that probably continues to surprise FIC as a company the most, is that, so we have this .org site, and we have this wiki. There's unbelievable amounts of content there. It's been translated, I think, now to 7 different languages. All of the documentation, okay, unless we have an NDA, we can't put this on there. Everything that we use, all the development tools, all of the resources that we read, all of the, our tool chain, literally everything that we do for development is here. We use the same things that you guys can use. The Bugzilla, every software issue we have is in there. There's some hardware stuff that we can't put in there because it's under NDA with vendors, unfortunately. But everything we can put in there, it goes in there. Planet, you can read about some stuff that we're doing. Projects, there was some problems with that. We're still working with it technically, but this is going to be where you can post anything you want to do related to OpenMoko software. Lists, mailing lists, we got a whole bunch of these now, I think around 10, 15, something. Going over different parts of the project. Yeah.
3,900 subscribers.
Yeah, 3,900 subscribers. Yeah, so I mean there's lots of traffic. We can't keep up anymore. Try, but we can't keep up anymore. So OpenMoko, everything we have in here is free and open source software. There is this existing design, this GTA 01, this is our first version. it uses a proprietary library and user space from a company called GlobalLocate, which in the end, Harald will tell you a little bit more about our plans for the next device. It won't have that proprietary library, put it that way. And so, okay, so well, why do you want free software? Why does this matter? Well, what it does is that it gives you access to what I like to call the building blocks of the phone. It gives you access to the hardware, where you can really change these things and make the phone do things that aren't even really phone-like. Jay's sort of showing us some stuff that he's done the past couple of weeks that are like, I mean, it's really cool. It's really, really cool. Nothing to do with a phone. And that's the cool part about it, because it's free and open source software. And the other thing, I think this is important whenever we go out and speak, I want people to know that actually most of the development is not done by FIC. If you look at how much code we've written versus how much code outside people have written, it's unbelievably disproportionate. So we fund it, pay for this, but you know, the real work, the real power is outside the community, and it's all free software. So you don't have to worry about a corporation, you know, taking this and saying, hey, we're going to make you pay for this. No, we can't do it. Even if we wanted to, we couldn't do it. You could just fork it and do what you want with it. So there's no vendor lock-in, which is really, really huge. Why now? Like, why does this work now? I mean, why is this really starting to take up so much steam? Why is there almost 4,000 people on the mailing list? What's going on here? So, well, we think it's because in the last couple of years, you've seen businesses finally acknowledge that free software is a viable alternative. We've also seen the processing power and the memory of these phones increase to a point that it's realistic, it's reasonable to run you know, real desktop Linux libraries on here, real existing software from the free and open source software world. And the third is that these smartphones, they're the fastest growing segment now. The past 2 or 3 years has seen the smartphone just boom, shoot off. I mean, it's growing at a rate more than 3 times of the feature phones of all the other phones combined. Now, the problem is that no one to this point has released a free software stack for a mobile phone. You can go and you can get some, you know, Motorola's kernel now, but it's not complete at all. You can buy a phone. They call it the green phone. They try to say it's an open source phone, but if you look at the licensing, if you look at what's really going on there, you don't have access to the things you want to. All the phone stuff is closed. So sure, it runs some, you know, some open source middleware, and sure, it runs a Linux kernel, but it's not open. You don't really get to change the things that you want to change. So this is why now. Why us? So another key here is that we got guys on this team. Harald's been doing kernel development since '97. He's been using Linux since '92, right?
94.
94. We have another guy whose name is Werner. He's in Argentina. He's been doing Linux development since '92. He wrote the
Lilo.
Yeah, Lilo bootloader. He wrote, I mean, he just did all kinds of stuff. He has a PhD. We have another guy who, believe it or not, has a PhD in open source embedded middleware. He has a PhD in middleware. It's open source, so it's like, yeah. I mean, it's a really interesting team. The core group of guys are just unbelievably talented. So if you start reading this code, I think you'll look at it and you'll be like, whoa. Yeah. In fact, one of the biggest issues is that the people inside FIC have trouble even keeping up with this. I mean, the pace, if you've seen what we've done in the past 8 months, it really is remarkable. If you look at the state of the code and with the resources we've had, it's really remarkable. And so we have this really good free software, free and open source software experience. And then we're backed by a big OEM, a big ODM, a company that has their own factories in China, so we can just make phones. We can talk with vendors. We can say, hey, we want to get this component, but it's not open yet. Can you open this for us? This is what we're doing now. And if we were just a small company, if we were some, startup in Silicon Valley, could never do this. We could never make a phone. It's going to cost something like $3 million to make that phone, just from the hardware standpoint. And so these kind of costs, it's prohibited for a small company. And that doesn't include infrastructure, that doesn't include the factories, it doesn't include any of that stuff. It's just the amount of money it takes to make a simple phone. The amount of infrastructure. So we have this. And we also know some important lessons that we've experienced that are actually very sort of dear to us. It's this idea that proprietary is going to cause you problems. It really is. It's just going to bite you in the ass. There's no way of looking at it. And that open is power. The more open you are, really, the more power you have. And there's some companies we listed here that you've seen their dominance come from their openness. This is a really strange concept for lots of people, but when you get more open, you have a chance to get more dominant in a way. So, Neo, we made this phone. So, at this point, I was a product manager still, and I was thinking to myself, what do I want my phone to do? If you could kind of rethink everything, because we came in from the outside to start a mobile communications group inside FYC, and we didn't have any legacy code, we didn't have any of this stuff, and I started asking myself, well, how would you do a phone if you could do it from scratch? All over again. What's wrong with phones? What do you want? Well, you want something basic. You can make phone calls, of course, you can send messages. You want to be able to change things that are more complicated than ringtones and wallpapers. I mean, let's face it, right? Changing a ringtone, changing a wallpaper is something you want to do once a month or once a year. It gets boring. Okay, so being a guy who likes software, of course, I wanted to be able to have a phone that if I didn't like the way it worked, I could change it. And this means adding new things to it, this means taking things out. I mean, there's lots of things that on this Nokia phone that I have that I never use, I just pull them out. There's lots of things that I wish I could have that I can't put on there, I wish I could put on there. There's some little annoyances the way the phone works, it would be great to change it. And this isn't even if you don't have the ability to write the software, to change the software, there's literally hundreds of thousands, if not millions of people who can. And the way free software works is by people scratching their own itches. Everyone kind of gets together and does the things they want to do. And it grows collectively. So this was the idea. We wanted to have a phone that would have an application manager that you would be able to select which applications you want. And if you're a developer, you can make applications. They'll get put into this feed. The phone automatically updates itself. The standard things you get on any Linux PC nowadays. And easy to use, but of course easy to use is relative. So here's what we got. This is the first freed phone. It's totally open. It's network connected, location aware. It's quite funny. So we're meeting with all of these GPS vendors now, trying to figure out which chips that we can use that we can get totally open. And the first question they always ask is, what navigation application are you using? And Harold and I look at them and we're like, no, you don't get it, right? For us, location is something that's intrinsic to the phone. The phone needs to know where it's at so it can do cool things. Let me give you some examples. If we are having a meeting in this room, why shouldn't my phone know it's having a meeting in this room? So anytime I come to this room, we're talking and everything, it just switches its profile from general to silent. Or other stuff like when you get close to your work or when you go from your work outside, it just switches to loud so you can hear the ringtone. I mean, you can do all kinds of things that even the most complicated artificial intelligence couldn't even get close to just by your device knowing where it's at. It's just a really, really simple concept of, oh, I'm here, I want to do something because I'm here. and network connected. The first version we have GPS and Bluetooth, GSM. We'll have Wi-Fi soon, and then we'll get sort of both, you know, public networks and private networks. And it's $350 US, which, if you think about it, it's really quite reasonable as far as phones go. VGA screen, 285 dpi screen. It's just gorgeous. This is a magazine. I put this here because I loved this magazine when I was in high school. It's like my favorite magazine to read. It's Popular Science. This is this month's Popular Science. There was, if you can see, it's really small here, but it says 29 hot products. We were the #1 hot product, and the title says a smarter phone. This is like, you know, smarter than the regular smartphone. And yeah, anyways, so this magazine, by the way, is read by 7 million people every month. So we really think we're onto something here. There's lots of interest, and it's just the right time. So, technical, yeah. Stuff, and then at the end we can have a question and answer session. Okay.
This is the open phone. Literally open phone. Yeah. Maybe while you can appreciate the PCB photograph in the background, a little bit of background about myself. I'm doing free software since about 1994, about that time. I'm mostly known for working on the NetFilter IP tables project, so my background is in networking protocols packet filter. I'm one of the maintainers of the Linux packet filtering subsystem called NetFilter IP tables, and I'm also involved with various other projects, among them, for example, the GPL-violations.org project, which is tracking down license violations of the GNU General Public License. Yeah. Anyway, getting to my actual presentation. Here. Okay. So, the hardware of the first device. Basically, we have a Samsung 2410 processor at 266 megahertz. It's, as Sean indicated, a full VGA screen, so not like most of the other PDA phones or other phones that you can get which only have QVGA resolution. 128 megabytes of RAM. That's, again, like twice the amount of memory that your regular smartphone has today. The flash in this first model is only 64 megabytes, but we have a yeah, it's actually not listed here, but there's a micro SD card slot where you can put in micro SD cards up to like, right now you can get them up to 1 gigabyte in size, so it should provide enough storage that, on a device. It's unfortunately only USB 1.1. We will fix that in later versions of the phone. We have an AGPS solution for global positioning system, a GSM and GPRS chipset, 2 stereo speakers at 1.2 watts, and a Cambridge Silicon Radio 4 based Bluetooth chip for wireless connectivity. Now, for those of you who haven't done any embedded development or who are not familiar with the various SoC architectures, this is basically the details about the Samsung system on a chip that we're using. This 2410 Samsung is also used in many kinds of consumer electronic devices. At least, I mean, I'm from Europe. I would say the most widely available device using the same processor is the early TomTom Go GPS navigation, car navigation units. Anyway, it's a pretty standard embedded ARM system. You have an ARM 920 core with you know, SD-RAM interface, 66 megahertz external bus clock, SPI, I2C, SDIO, NAND controller, and so on. The GSM modem we're using in here is based on the Texas Instruments Calypso Yoda chipset, and it's just as proprietary as any other GSM chipset that you can find. So just like any other smartphone architecture, we have the phone part, which is in our case called the GSM modem, and you have the application processor side. And the phone part is just using a standard solution that any other phone uses as well. So it has its own ARM7 core, it runs a proprietary Nucleus OS, a proprietary GSM stack. That's basically all what Texas Instruments provides for this Calypso chipset. Now, there is just no other way to have a GSM phone. We would love to see like an open GSM implementation and have this all free software. But it's just impossible. I mean, we're already having a very hard problem providing the level of openness we have on the application processor side. On the GSM side, it's just completely impossible. But anyway, it is not a, how can you say, a freedom issue, because this is basically firmware running in an external chip, and it does not interfere at all with the free software part. The interface between this GSM modem and the application processor is based on official public standards. It's based on the GSM TS07.05, 0707, 07.10. These are standard documents that everyone can download from the European Telecommunications Society. So even though the actual implementation of this firmware inside the GSM chip is proprietary, all the interface exposed to the Linux side is completely openly documented, and anyone can access these documents. You don't need an NDA, you don't need to register, you don't need anything. You can just download the standards and you can talk to the GSM modem. It supports quad band, so you can use it all over the world, and it supports voice data fax calls and GPRS for packet switch radio. The free software stack we're using on the Samsung application processor starts with U-boot. I'm not even indicating a U-boot version. Oh, the slide is actually old. We are running 2.6.21 now on the phone these days. So we're following both the mainline Linux kernel and we're following the U-boot Git version. We have KDrive as X11 server. We run the full glibc, no UClibc or diet libc. This glib, GTK+, and then our own basically additions on top of the. So this is basically the existing free software stack, and on top of that we have our own libraries such as libmoko UI for user interface widgets, libmoko core, and the GSM infrastructure libgsmd GSMD. But this is all free software. So whatever we write when it comes to libraries is LGPL licensed, and whatever we write when it comes to applications is GPL licensed. And whatever we extend will always obviously follow the license of the upstream project. So if we write an X11 driver, then it will be MIT licensed. And if we write a kernel driver, then it will be GPL licensed. There's no other way. The development model is actually the open source development. There's no OpenMoko specific part of it. So all the code that gets added to this project is done by people who are from the free software community. So this is not any company like FIC trying to push their stuff into the open source project. But FIC is funding free software developers such as myself to be able to work on this project. And we actively contribute our code upstream. Our goal is to make the vanilla 2.6.22 kernels have all the drivers. So you can just take the mainline kernel, not apply any patches, run it on the device, and have full device support. The build system is public, so everyone can rebuild everything. We don't even publish, we don't only publish, here's the kernel source code, here's the U-boot source code, but we publish the full build system. So if I can take any kind of computer, it doesn't even have to be x86. I can take a PowerPC system, I can take a Spark system, I can take an x86 PC, and I run basically a script called Moko makefile And this script then starts downloading our build system, which then in turn starts downloading the source code for the tool chain. It starts building the cross tool chain, building the cross linker, building the cross assembler, compiling the libraries for the target architecture, compiling bootloader for the target architecture, compiling the kernel, and so on, building the actual packages from this, and from the packages then it builds a firmware image. So anyone can rerun the full build process. And this system is based on OpenEmbedded. And we actually have one of the core developers of OpenEmbedded in the core team of the OpenMoko project. One of the important issues for us is to create a hackable device. So the device shall be under full user control, and everyone should be able to hack it at any possible level. This starts from hardware hacking. We actually have documented test pads on the PCB where you can put your own wires and you can add hardware components to the hardware if you want to. So we have I2C, SPI, GPIO, and one interrupt input on test pads. So you can, if you want to add some additional hardware, like you want, for example, to add an accelerometer or some, I don't know, whatever kind of component, you can actually do that on that. System level hacking, you can bootloader and operating system are fully entirely open source. You can change whatever you want, and obviously you can also do development and hacking on the user interface. One of the other goals is to make the entry barrier for development as easy as possible. So what we actually have is the bootloader has a command line interface. And on this command line interface, you can basically control the device. You can read files from SD card. You can access the flash chip. You can do about anything. And this prompt is available using USB serial emulation. So if the bootloader of the phone is running and you connect it to a PC, you see a virtual serial port coming up. If you connect to that port, you can access the bootloader and you can explore the device, and you can do whatever you want. Then we have obviously a serial console, and we have JTAG for the people, which means that JTAG is not a sort of development tool internal inside the company, but everyone outside there who's interested in doing system level development has JTAG access. And not only do we have public JTAG access, but we also provide you with a board called debug board. And this debug board I will talk about later. It's basically a piece of hardware that includes the JTAG ICE system, so the JTAG adapter. So you don't even need some kind of expensive JTAG equipment or any proprietary software, or buy some commercial JTAG solution. But you get the debug board from us, and using the debug board, you can over just one USB cable, you can access the serial console and JTAG of the device, and you have full control. So you can single step through the code, you can reset the CPU, you can access GPIO pins, you can do about anything on the lowest possible level, and on the higher levels, obviously as the tool chain and all the source code is available, you can do any kind of development. Another thing is that we actively want to have this device standards compliant. So whenever there are open and or documented and or available standards, we use them. So for example, for updating the firmware of the device, firmware is basically the entire software stack, we use the official USB device firmware upgrade protocol. So the USB Vendor Association has defined a protocol on how USB devices should update firmware, which about nobody implements apart from us. But anyway, if there is an open standard, a public documented standard, then we rather implement the standard than inventing our own thing. This is basically the policy. Our chargers, for example, also behaves 100% to the USB specification. We don't want to have anything that violates specifications at just for reducing costs or for making a solution quicker into the market or things like that. We want to do the right thing, not some quick hacks and dirty tricks. The GSM chipset, as I said, it follows the officially published GSM standards for the protocol side. So this is again under standards compliance. User control is another aspect of this. If you look at traditional phones, then the phone is controlled by anyone but the user. So if I, like the Motorola A780, which I use as my regular phone so far, I buy this and I pay something, I don't know, 2 years ago it was something like 400 euros or something. So I spent 400 euros on a device which is totally controlled by the operator and the device manufacturer, but not by me. You know, so why am I paying money for giving somebody else control? And this is what we are in OpenMoko. We do completely differently. So the phone needs to be under the control of the user and the free software he chooses to use. Like even some malicious backdoor in a rogue GSM firmware shall not be able to intrude the privacy of the user. So even if you believe in conspiracy theories about governments putting backdoors in phones to spy on their citizens, it doesn't matter. The audio codec, which is under explicit control from the Linux-based free software stack, can just mute the audio channel. And so no matter how many backdoors you have in your malicious GSM stack, it doesn't matter. Even we can cut the power of the GSM modem from the Linux-based side, so the free software remains in control. And if you want to have a 100% secure and trusted environment, then you can audit all the free software code. You can look at the bootloader, you can look at the kernel, you can verify the libraries, and you can basically make sure that there is no privacy invasion going on. Also, I mean, if you want like encrypted storage for your data to make sure that nobody can read your personal details or read your messages without authorization, we just use device mapper crypto, like any Linux desktop or server system can use for encrypted file storage, and which basically means free software, and in the end the user remains in ultimate control. We don't put arbitrary restrictions on the device on whether or not you can download ringtones or graphics or MP3 files or whatever onto your phone. It's open. You can use USB, you can use Bluetooth, you can use GPRS. It's your phone. You decide what it does, not the operator and not the device manufacturer. So, a couple of words about the GSM integration. So, we have something called a line discipline. I don't know how many of you are familiar with the Linux TTY layer, but it has a concept of line disciplines, and this line discipline implements this 07.10 multiplex. There's a user space GSM daemon, which has a Unix domain socket, and applications talk to this Unix domain socket to perform any kind of GSM-related tasks. Also, this basically implements you could look at it like a message bus. So whenever there's an incoming call, any application can register with the GSM daemon and get events once there's an incoming call, so you know like from which kind of number and so on and so on. It's lightweight. It doesn't have any dependencies apart from glibc. So it's really low-level, lightweight code. It doesn't tie at all into the user interface. So you can run this device without a user interface if you want. There's a G-object integration for easier integration to TGK. Oh, I need power. Sorry. I need to connect my power supply, otherwise the battery of the laptop will run empty. Huh? Okay. Yeah. Okay. And just to show how much we are committed to free software and how little we care about like this, FIC. Little we care is the wrong expression, but like OpenMoko is supposed to be a platform, and it's obviously FIC produces devices that officially support OpenMoko and that officially ship with OpenMoko, but it's free software. And we want to have a flexible solution for GSM that can be used in any kind of Linux-based smartphone design. So they have, I don't know how much of you are aware of this, but there's a group of developers who like erases Windows from HTC devices and flashes Linux into the flash. And they are already using the GSM daemon that we designed for OpenMoko. So it already runs on a number of the HTC devices. Also on the Motorola EZX phones, which the Ming is one of them, they also can run this GSM daemon. So we will not only support the GSM chip that's in the OpenMoko, but in the Neo 9073, but in any kind of phone. So the difference from other Linux phones is other Linux-based phone vendors discourage third parties from writing applications. So you need explicit permission from somebody to write an application for a device that you bought. I mean, this is just, to me, it's completely mind-blowing. I mean, I'm buying a device. If I'm buying a PC, then I take it for granted that I can, write and install applications on it because it's my PC. But on a phone, I buy a phone, and it's not my decision. It's the operator's decision or the phone manufacturer's decision, and that's just completely wrong. Others try to make customers pay for a device that's still under manufacturer GSM operator control. Yeah, I mean, if the operator and the manufacturer wants to control the device, then they shouldn't make me pay for it. If they want to rent me a device, that's fine. But if I buy it, I should be under control. Others use proprietary kernel modules. We don't use any proprietary kernel modules at all. All the drivers that we have are completely open in the kernel, and we will not ever put any proprietary module in the kernel. This is also important for our mainline merging strategy, because we want to support always the latest and most recent kernel. And if you use any kind of proprietary modules, then obviously you're fixed to some certain kernel revision. We don't use any proprietary bootloaders like other manufacturers of Linux-based phone. Other manufacturers don't give you any JTAG or serial access. Instead, they make it hard for you to get there. There are now even processors which have encrypted JTAG to keep people out. Other vendors use proprietary user interface toolkits to lock, if you write an application, to lock you into their architecture. We don't do that. Other manufacturers don't give you the build system, and they don't give you the firmware update tools. This is we all give this. So what kind of hardware do we have ahead of this current device? So right now we're in the prototype stage of GTA 02, which is the successor of GTA 01. It has the same case, physical size, same screen, same GPS. We want to change that, but we might need to fall back. It's going to have a Samsung 2442 processor at 400 megahertz. We have more NAND space, 256 megabytes. We will have 802.11b and G Wi-Fi. We might have Edge, it's not entirely sure, better power management, and a dedicated graphics processor. So we're really making a technical step forward in this idea. And then we have 3 more devices about which, unfortunately, I can't really talk. So stay tuned for upcoming devices. We're definitely going 3G with these devices. We're definitely going for even more integration of all kinds of peripherals. What actually is not listed on this page is that it will have 2 3D accelerometers. So any kind of physical movement of the device can be detected. If you rotate the device, if you turn it around like this, yeah, if you shake it, if you tap it, this can all be detected through 2 3D accelerometers. Yeah, and for those devices, as I said, I can't really give you any public comment on it, but it's definitely exciting. And we're talking to a number of hardware manufacturers about their policies and opening specifications, opening up documentation, and having actually quite good success in it. It just needs time. You need to sit down, you need to make them understand why it is important for them, you need to educate them about the free software development process, but it's actually worth doing. With regard to graphics, it might even happen that Linux mobile phones might have more open graphics than most Linux desktop systems. Yeah, well, that's basically it. Thanks for your attention. If you have any questions, then Sean and me can respond to these questions. I'm going to give you a small demo. Let me just find the right window. No. Where's the? Oh, I have it here. Stylus. Okay, so this is a small application that I wrote 2 years or 2.5 years ago for my Linux port on Motorola phones. And it basically reads the frame buffer on the phone and transmits it over to the PC so we can show it in the Windows. This is not a simulation, this is basically the real screen from the phone, just copied onto the device and shown on the screen. So this is just to give you an idea how this user interface looks like. So on the top you obviously have the usual icons. You have a battery indication where right now it says it is connected to power, which is USB basically. And you have, Bluetooth, USB, the clock. Well, the clock is not set correctly. Obviously, it's not almost 1 a.m. Now, to give you some idea about the applications. Now, I'm clicking on the application. It takes a couple of seconds until the next screenshot is transmitted to the PC. Here you see a startup indication. There's still some graphics problems. So this is a demo for the finger application. We have two kinds of applications. One application is finger-based applications, where you use the finger on the touch screen, and the other set of applications is for the stylus. By the way, this stylus ships with the devices. You can have it as a pen or as a stylus for the touch screen, and it has a laser pointer and a light. Yeah, so anyway, this is the finger application, so I can tap on this left button, for example. Unfortunately, it doesn't work here. So we have this finger wheel at the bottom, which you can use for scrolling. Then we also have the finger buttons, which will just show up here on the bottom. So applications can use these kind of buttons. It's basically a demo of the kind of widgets we use. Let me close this finger demo. Then let's look at the stylus demo application. Again, it takes a couple of seconds to transmit the image. Also, the phone is significantly slower because it needs to do all the image compression and transmitting over USB. Yeah, so this is basically the layout of our stylus-based applications, where you have the top section, which is for listing or for navigation, and at the bottom you have the details of something. I will show you some real applications. Obviously, we have a drop-down menu, which you see here. Some sample menu entries closed. Anyway, it's just a demo. So let's start, for example, the calculator. The calculator, by the way, is a contributed application. So this was not written by OpenMoko or FIC. This was just somebody in the community who said, "Oh yeah, the calculator has not been implemented yet. Let's implement it." So I can, I'm using my finger now. It's 59 is what I typed. It can take some time. So multiplied by 12. Who is faster than the screen? 708. Okay. Let's close the calculator and go again for something more sophisticated. Yeah, the user interface is really, it's very slow due to the graphics transfer to the PC. What's going on? Anyway, let me show you the task manager. Well, the usual problem of demonstrations. Something strange is happening. Ah, no. Okay, maybe it's just the touch screen is not calibrated correctly, I guess. Yeah. It's not calibrated correctly. Okay. Now let's, for example, start what can we start? The calendar application. It's called Dates at the bottom. So, this is basically now, as you can see, the same screen layout as the stylus demo, but an actual application. So I can mark some time here down there. You will see just in 2 or 3 seconds. I can mark a time frame, and I can start a new entry of whatever kind of appointment I might have at that time. Yeah, so there's still some color problem, as you will see right now. Yeah, so obviously the red doesn't belong there. But I mean, as you can see, it's not entirely finished yet. But what you will see right now is the keyboard, which will pop to the on-screen keyboard. You will see it just right now. And yeah, I can go into the summary field or the details, and I can enter ASTF, PPP, whatever.
That's some Chinese. There's a Chinese caption.
Yeah, there is a button for Chinese input method. If you check the button will change color. The problem is that we are lacking Chinese native speakers who support this project, developers. Like right now, all the user interface development is done by people in Europe. We haven't managed to get this kind of community input or the kind of feedback from the Taiwanese and mainland Chinese Linux community so far. The applications are mostly developed now in Germany, UK, and in Argentina. Yeah, and obviously people there don't regularly read or write Chinese, so that's why the input methods for Chinese are missing. So obviously, if any of you feels interested in working on this, we would be happy to learn about that.
Talk to me.
Yeah. So anyway, that's basically so far for a demo. There's also main menu, which I'm going to show, but then I guess we will just take some questions now from the audience. Yeah, questions?
Questions?
In the next version of the OpenMoko, it will have Wi-Fi support.
Yes.
But most of the Wi-Fi vendors, they provide the firmware in proprietary format. So how do we deal with that?
Yeah, so the question was, how do we deal with proprietary firmware of a Wi-Fi chipset? The answer is, proprietary firmware never is a problem. Even if to talk to Richard Stallman or to the Free Software Foundation, proprietary firmware is not a problem. As long as the driver side and everything that ties into the main processor and everything runs on Linux, the drivers are free, the firmware in some separate processor is a totally different issue, and it's not a problem. So what we're using in the next model is an Atheros AR6001G, no, GL. Yeah, AR6001 GL based chipset, and it has its own internal ARM7, and the Mac layer runs on that ARM7, and it's proprietary, but the entire driver stack on the Linux side is completely GPL licensed and open source. So that's the situation for Wi-Fi. It's just like Bluetooth, where also we use a CSR module that has its own ARM7 with proprietary firmware inside, but everything on the Linux side, everything on the main processor is free software once again.
GSM2 is the same thing.
Yeah. It's basically the same situation. Okay, any further questions?
Will you have an emulator or simulator on the PC that is the development of the application?
Oh yeah, it's already there.
Yeah.
There's a special version of QEMU which emulates the entire device, including the Samsung processor, our power management unit, and all the hardware components. And you can download from our build host, you can download the latest firmware image, and you can run it inside this emulator on Windows or on Linux, and you can experiment with the environment. And since all the tool chain and the build system is open source, and it's also again entirely public, you can use this build environment. You can write your own applications and you can run them. For application development, it's actually way easier to start writing the applications on x86 or on your whatever kind of workstation you're working on, because all the libraries we use, they just screensaver. They just they are just based on GTK. So you can, like all these applications and your own applications, you can just compile them for x86 and run them on your laptop as long as you're developing them. And then once you think it's at a fine stage, you can cross-compile and run in the emulator or run on the real device if you have one. That's basically the strategy. So there's no problem at all. And when it comes to all this development process, we don't differentiate between like internal development or external development. Our Subversion server is public. Like every day you can follow the code. Right now I'm writing the drivers for the GTA 02. We don't even have hardware yet, but the code is already there. Like our Bugzilla is open. So basically you can look at the software even before it ends up in any kind of device. Yeah. Back there, yeah.
How do I acquire this on the phone?
Sorry?
How does he acquire that phone?
Oh.
Question for him.
Yeah. Okay, so we just moved the production from Taiwan over to China. Here we just did like low volume, a couple hundred phones, and we moved over to China for the real mass production. And so I think that probably the end of this month, very, very early next month, we can have phones and you can just, I guess, come to FIC and buy them from us. We're also going to have it online, but there's this weird thing where we can't sell the devices yet online in Taiwan.
Why?
Why? It's some sort of like import. We have to apply for this import permit. It's really weird. We can import them and ship them out of the country, but we can't sell them in the country yet. But if you come to FIC, I'll sell you one. Don't worry about it. I don't care. Yeah.
Okay, it's the first time I hear about this. But
Yeah.
it's like
Yeah.
some Taiwan regulation.
Yeah. It takes a couple of months and then we'll have it official. But yeah.
Yeah.
You can. Yeah.
What other sort of thing needs to be done except for Chinese input?
Ah, good. Good.
Oh, there's tons of stuff
Yeah.
that needs to be done. I think the easiest way to find out is to either log in our Bugzilla, because there it also lists like, you know, this application is missing, this application is missing. And in the wiki we have the full application specifications. So I cannot show it here because I don't have internet here, but if you go to wiki.openmoko.org, for each and every application there's a specification on how this application should look like, you know, how the icons look like, what kind of user interface it has, we think it has, but it's a public wiki.
Yeah.
So if you don't like the specification, you can edit it.
Yeah.
So this is basically will help you to find out about the missing pieces of the system. Also, as soon as you run this in an emulator, for example, you will find out that, you know, certain pieces are missing, this is not working, that is not working, we're looking for input in that area. FIC is also hiring, by the way, so
Yeah.
if you're looking for a job working on free software development paid, then you might want to consider that.
Do they pay well?
For this project, yes.
I can't comment on that.
Yeah. Yeah.
Yeah. Okay.
Right here.
Oh yeah.
Yeah.
Sure.
I got two questions. The first is, how about the schedule for the next product that equipped with Wi-Fi?
Yeah.
And the second is that possible for education institute to buy your debug board?
Oh, the debug board is available to anyone. Everyone can buy it. So basically we have two sets for this first phone. The first one is basically the phone plus, you know, one of these, I don't know how you call them. Anyway, you know, so these things. It also has the stylus, it has a battery, it has a pouch, and basically a regular phone set, you know, headset and everything. And then there's the developer kit, which is I think $150 more. So it's like $500, but it includes the debug board and some additional accessories for doing low-level system-level development. And for educational institutions, get in touch with Will, get in touch with Sean. We are working on special offers for educational institutions because we think this is an ideal platform for universities to teach embedded system development, mobile communications, operating systems, these kinds of things. Because like all the components we use, like the power management unit, the system on a chip, everything, you can download the data sheets, and you can really understand this hardware down to the last bit, and you can, you know, have students re-implement certain drivers, or you know, just for educational purposes. Yeah.
I have a question. It's more likely about, maybe it's a pretty basic question. It's about, like, I know that cell phone companies, like mobile carriers in the US, they have like their company's their SIM card tied to the phone, that it's like bound to each other. So would this happen to OpenMoko, since for example, if you have Singular carrier phone with their company, would it be tied to Singular? Or we have to get the phone from their company? And,
so there is nothing in the SIM card spec that lets you lock the SIM card to the phone. It's the phone getting locked to the SIM card.
Okay.
So it's all free software. So if someone actually locked it to the SIM card, you could just
So will Singular sell your phone?
Sorry?
So will Singular or T-Mobile sell your phone in their
You would have to ask them, not us.
Yeah. Like, we're talking with some of the carriers, but like Harold mentioned before, we're actually really interested more in the education market.
Oh.
Yeah, but we're definitely, I mean, our plan is this thing comes in 3 stages. It's this what we call phase 0, and then phase 1 and phase 2. And phase 0 is when we sell, or we give, I should say, free phones to like really, really high-profile people in the FOSS community. And then phase 1 is what we start this month, next month. We just sell these things as kind of more or less developer devices. And then phase 2 is to the end user. And phase 2 probably sometime September, October-ish, around there. And then that, I mean, if carriers want to buy it, it's great.
But so we think it's much more realistic to, first of all, direct sales, and then go through the sales channels of the traditional PC market. So like you can go to Fry's or these kind of places where you can buy PDAs, you can buy laptops, and you can also buy this kind of phone. Because those stores also address a slightly more technical audience. Because it's actually, as Sean indicates, it's more than a phone. So it's a mobile, like, computing device, and among other things, it also has a phone built into it. And that's basically the situation.
Are there screen language support in current stack?
What
Script languages.
script languages? Oh, well, I mean, it's just a Linux system, and it has a packaging system. So you can install Python, you can install Perl, you can install Ruby, you can install whatever you want. It's just a Linux system. I mean, it's up to you what you do. For our own user interface widgets, there is a project, like again an external project, where somebody is providing Python bindings for our user interface widgets. But really, I mean, this runs an X server, this runs GTK, this runs glibc, this has a package management subsystem, just like dpkg and apt-get and so on. And you install whatever kind of packages you want. Think of the OpenMoko as a Linux distribution for mobile phones. That's what it is. So if you want to use a certain scripting language, or if you want to, I don't know, use Haskell or you know, something similarly obscure, then feel free. Okay. Well,
one more back there.
Oh, sorry.
Yeah.
Yeah, so this the current status of the. I don't have a SIM card in this phone right now. We can no. I have another phone somewhere. This one should have a Taiwanese SIM card. No, this one. Oh, this actually has a SIM card, I guess. Let me check. Oh, it's also available in white, by the way. White and orange.
Pink.
No pink so far. Okay, now I can show you a bit of the internal. So let me just start a new terminal and oops, increase the font size. Why doesn't it want to increase the font size? There we go, huge. Okay, now, oh, can we just, look at that. Okay, now, I'm going to SSH into the phone. Now, this is the phone. Here you see ARM 920 CPU, hardware GTA 01. You can look at the file system. So right now it's 32 megs of free flash space and so on. I'm just giving a sort of a low-level technical demo of the interface. We can make the phone call in like 5 minutes or something like that. Now, for example, if I want to know, where is it, the sys bus platform drivers, no, devices, no, sorry, I2C, devices. So, for example, this is the power management unit driver sysfs interface. So if I, for example, want to know the voltage of a certain regulator, then I can just see, well, D1 reg is obviously switched off right now, or maybe there's a problem. Ah, okay, yeah. Apparently, yeah, let me charge mode, for example, you can see it's currently fast charging with constant current, constant voltage and everything, so you can really have access to all the buttons and everything. There's also a file right now about the GSM log. Okay. For some reason it doesn't, I wasn't prepared about receiving calls. Let me just, give me 1 second. That's strange. GSM part seems to be working. Give me 1 more second. I mean, this is the phone I'm doing software development all the time, so this is not any kind of stable snapshot or any kind of release software. Yeah, this is much better. Okay, let's wait until it's registered for a network, or registered with the network. I will then tell you the phone number, and then you can make an incoming call. Ah, okay. So yeah, okay. Now it's registered to the network. Now let's switch back to the user interface side. Ah, there you go. Oh yeah, obviously it reacts slow. I forgot about that. Okay. Now, let me show you the phone number that you need to call. There you go. Let me enlarge it so you can read it. There. Do you have the number?
Yeah, I'm done.
Okay, now let's look at that side. Oh yeah, the call is actually coming in. So for the technical people, you can see here, this is the incoming line. And I can call again. But there's a text mode interface, which works obviously. It's just a graphical, to make a call again. Here is the incoming call, setup, sync, and so on, and I can now hi there. Yeah, it actually works.
The GUI works as well.
I'm just not the GUI guy. I'm not,
If you say Harold's computer, it doesn't have a GUI.
Okay, anyway.
So any more questions?
Oh, I guess we can start the informal part.
Yeah.
好，那我们谢谢兄跟 Helen。我想各位如果还有问题的话，我想大家可以到前面来，然后可以一起讨论一下，如果各有任何问题的话。那剩下时间大家可以自由讨论，这是我们平常聚会的一个方式。谢谢各位今天来参与我们的活动。谢谢。